Turns out that the chemistry of acids and bases shows up in many places that matter to all of us. Let's zoom out from our little teacup and think very big picture. Let's think at planetary scale, the scale of the entire Earth. Among the most spectacular forms of life on Earth are coral reefs. They're critical for the diversity of fish and other marine life, and ultimately for all of us because global ecosystems are interconnected. Corals are made of a chemical compound called calcium carbonate, and the chemistry of calcium carbonate is very sensitive to the balance of hydronium versus hydroxide ions. That's not true only of corals. Many critical marine organisms are made of the same stuff, of calcium carbonate. Let's do a quick demo to show you just how sensitive calcium carbonate is. Now, this is a demo that you're not going to be able to do at home because we're going to use some strong acid. And I'm going to put on some safety goggles here. And since I'm going to be handling acid that's not the safest in the world, I'm also going to put on a pair of gloves. So what I have here in this flask is essentially powdered coral. It's calcium carbonate, powdered and inserted into the flask. And what I have here is hydrochloric acid, 6 molar hydrochloric acid, which is pretty strong stuff. It's not something that you have in your home. And I'm going to take some of this hydrochloric acid and I'm going to add it to the powdered calcium carbonate, the powdered coral. And we're going to see what happens. That's a pretty vigorous reaction. What's happening here is that the calcium carbonate and the HCl are reacting, neutralizing the acidity and forming carbon dioxide gas, actually, is what's coming off of here. Fortunately, no one is dumping huge amounts of HCl into the oceans, but all of us are contributing to putting carbon dioxide, CO2, into the atmosphere, and that's from burning gasoline and other fossil fuels. When that CO2 dissolves in water, it makes an acid, carbonic acid, H2CO3. That's a very weak acid, but it makes a difference. It's making the oceans more acidic than they would otherwise be. We call that ocean acidification, and it's a problem. It's making life harder for corals and other ocean creatures,